progress at Lakeside Bank on West Jackson Boulevard. Be advised, assailants are armed and dangerous. Getaway car is a black Pontiac Trans Am heading southbound on South Clark Street.
Hello, OWASP Ottawa, and welcome to February 2022. I don't know what was on your 2022 bingo card, but I've had to throw mine out and try to find a new one. But all is well. So please, we'll continue with our regular meetup. I just want to review a couple of things in the PSAs, just to remind people about what's going on. Always be an OWASP member, lots of great perks. If you want to present at one of our meetups, please follow the link and submit an abstract and a bio, and we'll hope to have you at a future meetup. We are on all the social medias, and of course, if you're watching this on YouTube, you've already found us. We run our own Slack just because we had it. OWASP has their own Slack as well. And there's a jobs channel there, so check it out. What else? There's the link for the main OWASP Slack, so you can get an invite for members. And just a quick shout out to our volunteers who help get things together and help us maintain our sanity. This month, we are incredibly pleased to have Jim Manico to talk to us about things other than the OWASP Top 10, but specifically from the Top 10, Request Forgery on the web. Jim is the founder of Manico Security, and he's also an investor advisor for several films and author of Ironclad Java. He is also project lead on the OWASP Application Security Verification Standard, which is a name that you have to try to practice saying 3 times quickly, as well as the very important cheat sheet series. So without me prattling on anymore, welcome, Jim.
Gar, thanks so much for setting this up. It's definitely my honor to give a talk to all my good friends in Ottawa. I hear you're in the news. I don't watch. I just kind of given up on the news. I hear there's some Ottawa news. I know nothing about it. So I'm here to talk security, though. I want to try to lend support in some way to help all of you learn a little bit more about, I think, an important web topic. So I'm going to share my screen. I'm going to do it. It's sharing time. There it is. There's my main screen. Let's go into PowerPoint presentation mode. So hopefully you can hear me, you can see me, and you see a slide that says forgery on the web. Do I got that right? Can everyone see me okay?
Yeah, we got you.
Let's get to work here. So again, my name is Jim Manico, application security educator. Please don't hack without legal written permission. I'm going to show you a lot of hacking techniques. Use them ethically. If you're going to use open source libraries, do a vetting process and keep them up to date. I may mention a few. The first forgery on the web I want to talk about is straight up cross-site request forgery. This is when I go visit an attacker website. The attacker website drops code in my browser that makes a request to another site, which includes the cookie by default in older browsers. And so it's really that simple. And another way of looking at cross-site request forgery is like this. Suppose I'm at evil.com. I'm at evil.com, boom, 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 and these 3 images automatically make a GET request to Google, some server, and webmail. And in an older browser, by default, the cookie will be sent with this request if you're actually logged into these services. This deletes your messages, submits a banking transfer, kicks off an appropriate email, and this REL is no refer. That's actually erasing my tracks. So the referring URL, which is evil.com, is not listed. This is, in short, what cross-site request forgery is. You can even do this with a post request, right? Here's an example of post against a bank where I have an iframe that's styled to be invisible that contains this form, which automatically submits the form with the money transfer and bank transfer. And again, in an older browser, the cookie is sent automatically. Absolutely. One of the first recorded incidents of request forgery that I've seen was at Netflix. I don't want to use Netflix. That's not really fair. Some movie service that's not Netflix. Okay, I didn't mean to do it. So anyways, so we have a script here. This is the attack on a third-party site back in 2006 against some movie service that we won't mention. Here's the body. We load the image tag. That hits the some movie service JSON add to queue, and it moves this SpongeBob SquarePants movie into the bottom of your DVD queue. We then wait 2 seconds with set timeout and call load image 2, which takes that same movie and moves to the top. And now we just forced a DVD in the top of your queue that you never ordered. There's an old school request forgery. Now, let's take a look at Brazil. This is 2012 Brazil. A third of the country was using this router. In Canada, do you say router or router? Router or router?
Now I'm confused.
Okay. This router was given to a third of the nation of Brazil. About 5 million people were using that service. But there's a vulnerability in this router. Cross-site request forgery in the router. What happened was I can go and hit the change password feature without needing the original password and without needing to be logged in. Now, I can't hit the router from the internet. I have to be behind the router's private network. So if I host this attack and you're behind this router and this code lands in your browser while you're on the router using the wireless or similar, this form will request change password to 192.168.1.1, the local router. It will change the password to a known value that the attacker knows. And by script, the attacker will then change the DNS server, all by visiting a bad site. And now I control your DNS, game over. I can do phishing and more. So the point here is I can conduct request forgery against an internal network. You could be at work, logged in via single sign-on, visit an external website that knows your intranet and can attack your internet through this request type. So we need to stop this, don't we? We stop this with a variety of different patterns we're going to look at depending on the situation. Let's start with Synchronizer Token. This is built into most web frameworks, and it places a hidden token into HTML. The way this works is I log in, I generate a random value and put it in a session, and every time I render a sensitive form, I'm going to put that session token as a hidden variable, and I'm going to verify with each form submission. Does that random value match what's in session? If not, I'm going to reject it. This is the standard Synchronizer token pattern, an old banking pattern that we typically build in web frameworks to stop cross-site request forgery. Now, for doing APIs, if we have a browser-based application that uses cookies and uses an API that's stateless using JOTS, JSON Web Token, we can't use Synchronizer Token. There's no session. So when you're doing stateless API work, there's no client server, there's no server state. I'm going to send you a JSON Web Token and all the data I need for you to process it. To stop request forgery in that situation, I'm going to use the double submit cookie pattern built into Angular and similar. You've got to enforce it on your server. So I'm in an Angular or React or similar client. I hit submit. It's going to generate an anti-CSRF cookie on the fly and put a big random value there and put that same random value in as a custom header. Now I got that custom header and we submit this both to the API. The API checks that the cookie and the custom header match. And if they match, you pass the request forgery challenge on a stateless API that uses cookies in a browser. And so, whoa, wrong way. So one more note, an evil domain cannot read the anti-CSRF cookie to include it. That's what provides this defense. A few more things you can do to stop request forgery. Just do a re-authentication challenge. This is good for like step up for authentication for any sensitive feature. You got to transfer money, make me log in again. I want to change my account profile and credit card data, make me log in again. So this really stops request forgery pretty cold. Now, what makes this interesting is we have these new browser standards, right? These browser standards around the SameSite cookie is super powerful. This says if you flag a cookie as SameSite strict, that says a cookie will not leave the browser unless the current browsing page and the target server are the same domain. And a registrable domain is complicated. I mean, you can actually have like manico.heroku.com is a top level registrable domain because Heroku registered Heroku.com is a top level. So it's what a registrable domain is a bit complicated. But let's pass on that for a second. If the page and the server are the same domain, the cookie will be shipped. But if you're initiating the request on evil.com, let's go back to this, right? If you're initiating the request on evil.com and it goes to server.com, that's not the same site. And a same site cookie will not leave the browser in that case. Now, how good are web standards here? Every major browser supports this. Even the filthy piece of garbage junk browser that no one should use, known as IE11. You're dead to me, IE11. 3 more months, end of life. By the way, Safari, you can kiss my behind. Safari is horrible at modern web standards. You got to slap them around and scream to get them to do basic stuff. So I try to avoid Safari. I prefer to block it at the perimeter. Only fanboys use Safari and mobile iOS users. Oops, big user base. I'm moving on, just being snarky. Now, what makes things really interesting is around Chrome 76, 2020-ish, if you don't set the cookie as same site, then same site is lax becomes the default. Whoa! Overnight, browsers began automatically stopping forms of request forgery. Really well done, Mike West and Google security team and the W3C security working group. The motivation is stop request forgery. And what I like about this is SameSite LAC says if you click a link that opens a browser that sends a request, let the cookie fly. SameSite strict says you got to click inside a browser page that goes to a server for the cookie to actually be sent. So I like this global default of SameSite LACs. We saw this roll out and roll back and roll out, and we really saw it super wide spread beginning of 2021 across other browsers as well. Very, very important standard. And a few final notes here, right? Non-cookie session management does not benefit from same-site cookies. If you're using basic or digest or network-based session management, which is horrible, then you're still vulnerable to CSRF, and same-site cookies won't save you. If you give me control of your subdomain, like you use my service and you register like manico.canada.com or whatnot, if I control your subdomain, I can overwrite cookies. Subdomain sovereignty. Stop giving your subdomain away to other services. And it's a subdomain takeover is real. And not all browsers support SameSite. You may support older browsers, and that's going to be a problem. So what else? So a couple last notes here is you got to be bulletproof from cross-site scripting to stop request forgery. One cross-site scripting flaw, and I can do any forged request I want from in your browser. And here's the cross-site request forgery cheat sheet. I just did a big edit on this a few months ago. If you got a framework, use a built-in protection. If you got stateful software with a session, use Synchronizer Token. If it's stateless API that uses cookies in a browser, use a double submit cookie defense. And you got same-site cookies, consider re-authentication as well. Make sure you're bulletproof from XSS, and don't use a GET request for a state-changing operation, right? So GET requests should not need to be protected. Another old school kind of request forgery is our friend Clickjacking. With Clickjacking, a whole different kind of request forgery, I'm going to overlay a fake site on, and I'm going to go to some site, and I'm going to overlay a target site over your site and make it invisible by setting the filter opacity to be 0. And so I got an iframe, I'm loading Gmail, and I'm making it invisible. So when I'm here and look at one player, if I click on one player, I'm really clicking select all. And if I click on start game, I'm really clicking delete. So that's what clickjacking is. The way you stop this is typically you use X-frame option, deny, or same origin on the page you want to defend against, so they're not able to load your site in a frame. Because if your page says X-frame option deny, nobody else can load you in a frame. And to do clickjacking, the evil website needs to load the target site in a frame like this. And recently, we got content security policy now. So you don't need the X-frame option header if you're using content security policy with the frame ancestors call. A little bit better of a way to do this. Another kind of request forgery happens in the world of OAuth 2. So what I can do is, with the world of OAuth, I can force my bank account into your client site like Mint. It's a contrived situation, but the world of OAuth, this is a real request forgery in the world of OAuth. So I'm going to use Pixie, the proof key for code exchange, to stop request forgery with the OAuth 2 protocol. Now let's imagine this. So we got Mint as our client site. Mint collects all your banking information and displays it in a single pane of glass. And we got my bank, Bank of J. So I log into Mint and I say, please connect to my bank. So Mint sends a request out to the bank to connect to it and sends a hashing function name. And the result of that hashing function and saves the actual seed. That goes to the bank, and the bank saves it. The user authenticates and says, yes, let Mint use my banking account. And now we're redirected back to Mint. Mint is going to send the code verifier up to the server. And now the code verifier, that's the key, is sent into the transform function, which was set in step 1. And if it matches the code challenge, then we let this request go through. This is, again, and if we get the match here, we send access tokens to Mint so they can access my balance. This is request forgery in OAuth 2, right? Let's do one more. Let's look at server-side request forgery. So in August of 2019, we see that Capital One got hit by one of the largest breaches in banking history. There's a lot, I know, Equifax is a big one, but this is like 100 million records stolen, applications stolen from Capital One. Now, this attack happened by an ex-employee of Amazon who worked for AWS. He was fired or whatnot and decided to attack Capital One for some reason. So this is the attack. This is Capital One's domain, and there's a parameter in that website that takes a complete URL. So this is called a server-side include. The server is going to take that URL parameter, load that resource, embed it on the page server side, and send that down to the client. And so now what the Amazon Web Service attacker did was they realized that this is a standard location in AWS version 1 security API of how to retrieve the credential file for a web application firewall. So this is the local address for anyone in AWS. This is the Identity Access Management CRED folder with, ironically, the CRED file of your web application firewall. So that was meant to configure the web firewall. So this attack punched through the web firewall at AWS. It stole the web firewall's credential file. The attacker then logged into AWS directly. The attacker then navigated to the S3 bucket and stole 100 million records. She's now in jail. She's a felon, broke the law. Bye-bye. This is server-side request forgery. We saw this vulnerability both at GitLab in 2021 that allowed users of webhooks to attack GitHub's internal infrastructure. We saw this against Exchange a couple months ago, where Exchange had a server-side request forgery that would let me use the Exchange domain controller account to pivot requests into your Windows network. This is brutal. Rooted like 30,000 companies across the US. So another way this problem can happen is when you're constructing a URL like this. Here's an n-tiered infrastructure, right? I have access to a public API, which then takes data from the user and sends that to an internal API. And so I grab the data parameter at A, I add it to a URL and make that request. Now, how could I change that URL and change the path here? By doing path traversal. If I say that my variable right here is that variable, if I use this as my attack, then that's the final URL. You were expecting internal data, but I did path traversal. Now it's internal admin, and I'm stealing data from your back end. How do you fix this? You fix this by URL encoding that parameter before you add it to a URL when you're constructing URLs. So if we go back to this, and we have to encode that parameter when we're doing URL construction. So path traversal leading to server-side request forgery is not possible. I went a little bit too fast. I'm almost wrapped up. I went super fast today. I just spent 8 hours teaching right before. I'm sorry, I went a little bit too fast. So here are some additional resources for you. What else do we have? And here's my final slide on this. And I'll give you a copy of this deck right now. I'll send you out a Dropbox link. So in order to stop server-side request forgery, we want great authentication on internal APIs. We want great access control on internal APIs, so no API gets a free ride. Like when we're doing these pivot attacks like this, if I didn't have access to the admin folder and my authentication token was propagated, this would have failed. But in a lot of cases, there is no authentication on backend services. So we should do that. The most important place to verify an active token is on your intranet APIs. When a URL is a parameter that you're going to act on, do very strong URL validation. Or how about avoid taking URLs as a parameter in the first place? When you're building a URL that the server acts on, URL encode parameters you add to it. And you can even wrap every individual service with like firewalls, network controls, and microsegmentation to limit what they can do. I went fast, folks, super fast. That's my talk. It's 53 slides. I just zipped through and at halftime. Now, what I'm going to do for you at the very least is I'm going to get you a copy of this slide deck and give you a chance to ask questions. First of all, does anybody have any questions about anything at all discussed in this talk?
I have a question.
Yes, sir.
So do you feel that CSRF is becoming less diabolical with the advent of CSP in modern browsers and mostly frameworks providing mechanisms themselves?
Absolutely. It's becoming less of an issue. But there are limits to this, right? Remember, the limits are, I wouldn't depend on SameSite cookies by themselves, because if you're doing non-cookie session automatic management, SameSite cookies won't help you. And like, for example, this is where I've been bit. HTTP basic session management, digest or legacy standards. I see some companies that use your network address for session management. These are all vulnerable to request forgery, even in the face of SameSite cookies. And if I can take over your subdomain, I can overwrite cookies and get around SameSite. And SameSite support is not universal, right? Understand what your browser support is. And if you're supporting older browsers, then you need additional defense discussed in the talk. But your conjecture is right on, is that request forgery overall, cross-site request forgery is way less of an issue. And most standard cookie sites are protected by default in modern browsers, with the SameSite lacks default policy.
Right. And the old browser, if the conformance level is to include old browsers, then relying on something like the origin header as being immutable is not really going to work in that case.
I try to not use the origin header defense. It's weak. I like to use the Synchronizer Token, double submit cookies. I forcibly configure my SameSite cookie. This is what I usually depend on. And in the future, if I know that I'm programmatically blocking older browsers, and I know for sure I'm only supporting modern browsers and I'm doing cookie-based stuff, yeah, default lacks cookies. We'll shut this down. It will.
Right.
What else you got?
Well, for me, does that also explain why the last time I was reading through the new OWASP top 10, I didn't see CSRF called out specifically?
It's really not a top 10 issue anymore.
Right.
I'm gonna go PDF. I'm gonna go Dropbox. I'll export it right there for you. I'm gonna give you a link to this in just a second. No, it's not a top 10 issue anymore because it's automatically protected in the framework. It's not something we see a lot of data for. It was absolutely the right choice to remove it from the OWASP top 10. There are bigger fish we need to fry this time around.
Right. Speaking of other fish, Reza asks, do you believe that, you believe that SSRF is going to drop out from the top 10 anytime soon?
It was just added. And we see a lot of those problems. So I don't think so, no.
So how much of
it may drop next version, but it's going to be in the top 10 for the next 3 or 4 years. Absolutely.
Well, given that everything's on the cloud now, isn't and I know in particular the Capital One Consumer Zero issue that you mentioned, the attack part of it was the API. Part of the problem was the API in AWS. So how much of that do you think is actually going to be based on the posture within the cloud vendor?
In general, a huge amount of the problems with SSRF is because of cloud infrastructure. So this is not going away. No way. I believe SSRF is, and Reza, the top 10 is a 3-year cycle. I bet at the next OWASP top 10 in 2025, that's when it's going to drop out. And it's going to be relevant for the next couple of years. We radically need to bring awareness to this. By the way, Reza, the data we collected did not show SSRF to be a top problem because scanners don't discover it well. We got SSRF into the top 10 because of the community vote, which was overwhelmingly voting plus for SSRF. So I'll say it's not going to drop out soon, but it will drop out in the next cycle. 3-year awareness will be plenty to get more awareness to this problem. How's that, Reza? Good question. It will go away. It will go away. Cloud, by the way, cloud, my whole courseware is turning into how to build APIs on AWS, Azure, and GCP. That's that's the future of secure, and GitHub, Azure, AWS, GCP, future of all API development right there.
I'll have to ask you about the link for any information on that course. So 3-year cycle for OWASP top 10. Should that be shortened?
I like, the OWASP top 10 is not something to base your organization off of, right? The Canadian government has a big awareness about the OWASP top 10. That is a huge mistake, in my opinion, because it's a super incomplete program. And it, just in my opinion, I've talked to the Canadian government about this. They've asked, and they're like, we got to start somewhere. I'd rather you start with ASVS level 1. That's a complete standard. But you know what? I'm not trying to diss Canada. You're doing something to promote web security. That's good. But I like the OWASP top 10 for presentations like this. And then I get rid of it. And I focus on the ASVS standard. Now, that's something that you can really base an application security program off. Let's go to GitHub and look at ASVS, right? Misspelled. That's okay. We'll find it. Nope. ASVS. There it is. And for me, I base my program off of this. These are the many requirements in the application security verification standard. There's a mobile version of this. You can just look at L1 requirements. I'd much rather you start there. The OWASP top 10 is really meant for conference talks, initial awareness, and similar. Let me add to that real quick. Let me just augment that for just a second. So let me pop up my OWASP top 10 talk for a second. And I'm going to show you a slide here. This is actually from the OWASP top 10 document. And what they're saying is, you want to breed awareness? OWASP top 10. You want to breed awareness? OWASP top 10. You want to do training? It's entry level only. Because one of 50 modules I teach, right? Design and architecture, occasionally. Coding standard, bare minimum, bare minimum, bare minimum, bare minimum, bare minimum. You want something comprehensive? Use the application security verification standard. This is one of the first pages in the OWASP top 10. It's not just me saying this. It's in the OWASP top 10 doc itself. I mean that with respect. I know you got to start somewhere. Yeah. The OWASP top 10 is a great place to start. I would just like to see, as that program continues, maybe year 2 or 3, you bring out the ASVS to be more complete in it. You got to start somewhere. I'm with you.
Well, I'm sure you, like many of us, will see a job rec for needing to know a requirement being knowledge of the OWASP top 10 standard. And so then we all cringe, right? So
yeah, exactly.
I'm just looking to see if we have any more questions at the moment. Not that I see any.
Garth, real quick, in SteamYard, I just tweeted out a Dropbox link to the PDF of the slides I used today. Can we get that out to everyone?
Yes. So I've shared it in the chat, the general YouTube chat.
Thank you so much.
That's there. Other than the things I mentioned in in the introduction, what else is on the future for Jim Manico?
I'm getting ready to hit the road again for the first time in several years. I'm doing a lot of talks at the different NDC conferences. It's mostly for fun. I like to travel. Time to get out of here for a little while. I'm back to I'm teaching. I've been teaching secure coding classes the whole pandemic. I'm ramping up marketing. I'm ready. I'm eager to get more business. I've been chilling for a while. I'm ready to get back out there. So I'm giving talks about security and fishing for training business. And I just bought a 30-acre ranch here in California. Biggest investment of my life. So
wow.
I'm going to be a farmer in my spare time, a dream of mine for a very long time. So I'm excited.
Right. So is it going to be like a vineyard or?
No, about 25 acres of good weed. No, I'm just kidding. I'm not. Joke. No. I would do it. No, actually, I would do it, but you can't.
It's legal there, isn't it?
It's recreationally legal for the whole state. So it's just so many people are doing it. It's not profitable. I'm going to do a vineyard, cows, goats. I'm going to have horse. I ride. I'm going to get a couple horses for the property. It's going to take time and money. So I'm renting out some of the land to other farmers for now. So it's a dream of mine. And so that's what I'm up to. I'll stop. I know I'll stop now.
So there's just a question showed up in the chat, and I have to pause here because even though this is OWASP Ottawa, but we are on an international media, we have someone who asserts that they're from Kenya. And so they have a question. Let's see if it'll fit on the screen. Using OAuth 2 for a client infra apart from form, X-frame, and content security implementations, would you suggest extra measures I would use infra?
I have no. Okay, I'm going to interpret that question as what should I do for better OAuth 2 security, right? So the document that I would read is the OAuth 2 security guide. Let me see if I can find it real quick. Yeah, this is what I'd be reading. The OAuth 2 current security best practices. And this is written by Fett and Lauderstedt, along with Bradley, who's one of the heads of the group. So this recent version is only 2 months old. So here it is. That's the OAuth 2 current security best practices published 60 days ago. Give that a read, and you'll learn a lot about modern OAuth 2 security. That's the best I got for now.
Awesome. Well, you've had a long day, so we really appreciate you joining us. He says he had a limited number of characters. So anyways, thank you. You've been on for what, 8 hours, so we'll give you the rest of your day back to you. So we really appreciate you you talking to us, and it's a pleasure to listen to you as always. I just that energy always makes me feel excited. So I really appreciate that, and we'll share your slides, and from there.
Why, Garth, you know why OWASP has gotten so big internationally and why OWASP is such a powerful organization? It's because, Garth, of leaders like yourself who volunteer time to run chapters and help lead the community and help do the work of running chapters. That's the lifeblood of our whole organization. So, Garth, thank you for all you do for us. My last note is I'm always looking for secure coding training business. Please keep me in mind. I'm jim@manico.com if you or your friends need secure coding classes. All right, I'm done. And I salute you all.
Thanks very much.
Have a wonderful day, everybody, and thank you for having me. I'll see you next time.
All right.
Good luck out there.
Bye-bye.